So when you store data in cloud storage, if it's in, I'm going to use Amazon's S3 as an example, but it could be Microsoft's Blob Store, you end up having to decide what kind of paradigm you want on top of that. So by our nature, we have a couple different kinds of data, and we have lots of data, but I'm going to, for the purpose of this, to make the discussion kind of easy, I'm going to break it into two major parts. We have unstructured data and we have structured data. So unstructured data can be irregular, it could be a media file. It's something that is generally hard to be machine parsable. It's not super easy. Like a WAV file is not really machine parsable. You got to run voice recognition against it, and then you got to, and the voice recognition, the conversation isn't structured in any way. It can be a rambling conversation, it could be anything. The same kind of thing with movies. PDFs are a structured document, but the data inside of them is unstructured. You have no idea whether the payment plan is going to be in a table, or it's an image of the payment plan, or anything else. There's no way you can say, find the payment plan in this loan document, usually. So structured data comes in, I'm going to pretend it comes in two different forms. We have columnar records, which would be like a CSV or any kind of row column table-y looking thing. It could be Parquet or ORC. There's a whole bunch of file types, and I know those can have nested columns, so they can be slightly non-rectangular, but let's pretend they're rectangular because that's the easiest way to consume them, and everything else gets kind of weird. And then we have non-columnar records, right? So that would be like an individual JSON file or a JSON file of JSON. So they're structured, but they're not kind of in that square format, and they tend not to be flat. Some systems can deal with JSON as if it's columnar records, but it assumes each of the top level objects in the JSON file is actually a flat thing. So there we have JSON. You could have Avro, you could have some graph database, which is totally not columnar, and that's actually really hard for kind of basic query tools to run against sometimes. I'm sure people will point out great SQL-ish or other query tools that are good, but that's not what I'm talking about here, or at least for the purposes of this discussion. So if we look at those three data, now that I'm thinking about this, I should put parsable here. I will fix that. So cloud storage is basically a giant bucket, a giant space, and in S3 terms, it's a bucket. And each item in the bucket can have its own unique identifier. I work at one place, and we have over 1 billion objects in storage, right? And they all have unique identifiers, and you can find them. And some of those are structured, and some of them are unstructured, and some of them are rectangular, and some of them are non-rectangular. If we look about how we operate against this, when you put data into a lake, into a big storage area, and a lot of people will treat that as a data lake, you can just dump the data in there. You can just pour it in, you just put it in whatever format it's in. And that's actually the primary way people retain the original copies of their data for regulatory reasons or because they want the original format. And then some of those formats may not be super usable. Like it may be that I want to take JSON and convert it to some flattened structured format so I can join the JSON data send against another set easily with standard tooling. It may be PDF. So I generate a bank statement, and every bank statement's got a trans record in it, and we want to reverse snarf that data into some place that we can work with the transaction records. I made those up. I have no idea what people would do with this. We can just dump everything we want in the lake, but people have really wanted to do big data analytics, and big data analytics means we typically treat them as some kind of table or some kind of regular format where we can join one data set against another and merge them or run business rules against them. So you could take a data, and those storage formats are optimized for loading, and they're optimized for the way queries run against columns. So a lot of them are columnar stores. And so what we do is we tend to if we have lots of data, what we do is we tend to partition that data so that we can take a lot of worker nodes and split those worker nodes off, each working on some subset of the data. So those are called partitions in a lot of systems. We actually kind of treat these like data warehouses, like giant data warehouses. A lake's capable of storing anything. So you can put files or objects in it, but you can also take those files and objects and arrange them as if they were a table. And I'm going to show you an example here. So the way this works is we might do a partition for every day or every week or every month. And then it turns out each partition doesn't have to be one file the way Hive and Spark and a bunch of other things work. Each partition can be a group of files, and each file can have an arbitrary number of rows in it. I made them all the same here, but that doesn't need to be that way. If you think about the way cloud storage works, it's immutable. Like if you have an S3 blob, an X3 object, you can't just insert stuff in it. You actually have to replace that whole object at once. So if you have slow moving data, a lot of data where a few things change a week, a day, an hour, a month, where some low percentage, it becomes really expensive to take that same data set and re-put it out there every time with new data in it. So what people do is they partition it, right? They'll put out a new version every day or a new version every week. And if you're streaming, you may want to put more data out there every minute or every 3 minutes or whatever. And so the way we do that is we make partitions, which are really just folders. And since in the cloud storage, there's not really folders, it just looks like a folder. And we can put new objects in that folder on a regular basis. And when the software looks at it, it believes all those files in that folder, in that partition, are actually one, treats them as if they're one giant file, merges them all together to make them one giant file to represent that partition. Now, if the partition is really large, you can actually have workers go in and work on subparts of that partition. But the idea is we have blob storage, which is kind of immutable. It can be replaced, but it can't be changed. And it can be of arbitrary data type. If we restrict ourselves to record-oriented data and we set it up in a certain way, we can treat those blob stores as virtual tables. There are more efficient ways to do this, but there are no more large data ways to do this. This has actually enabled us to store more data, for individual companies to store more data today than existed in all of data storage 25 years ago. May even be 10 years ago. I know one company I used to work with, they had 40 petabytes of data. And it's crazy. Like that used to be like you couldn't buy appliances for that. Okay, so what did we talk about? We talked about the fact that we have structured and unstructured data. We talked about the fact that structured data can come in different formats. We talked about the fact that if we know what the structure is, or we stick to a certain structure, we can actually map data warehouse type paradigms on top of this storage that is not actually optimized for that. And because we have so much compute power, it is actually possible to get decent or good performance out of something that wasn't even possible years ago. Because cloud storage is cheap, it turns out a lot of times we act like when I get files from third parties, from other companies, I actually want to keep the original file. And then if I want to use that data in my virtual data warehouse, I'll actually want it in tabular format. So it is super common that people will get a file that's columnar, columnar, or JSON, and they will convert it into a partition table set so that they can work on it as if it was a data warehouse. So don't worry about blowing storage. It's relatively cheap. You can store it in multiple formats. Some people will take the same file and put it in multiple different formats to optimize the query performance. What do we do? In wrap up, cloud-based storage is super cheap. You can store data in any format you want, and you can store multiple copies in different formats. It is possible to make paradigms that treat Blob Store as if it was a set of tables so that you can do SQL and other query-like joins against it. You can do this with other data types too. But if you have large amounts of structured data and that data changes over time, you can use these virtual table formats while also retaining the original data. This means you can support file uploads, file transfers, streaming data, message-driven data. All of that can be stored and mapped into cloud's blob storage if you just put the right paradigm on it. Time's up. Have a good day.